AI-powered data-driven decisions enable businesses to leverage machine learning algorithms, such as Random Forest, to analyze historical data, predict trends, and optimize decision-making. By integrating AI models with real-time data, organizations can enhance forecasting accuracy, streamline operations, and improve resource allocation. This approach minimizes risks, maximizes efficiency, and provides actionable insights, allowing companies to stay competitive in a rapidly evolving market. Pradeep K. Suri, author, researcher, consultant, and AI/ML architect. The Random Forest K-fold cross-validation graph can be used to generate insights for different management levels from customer order, production, dispatch, and feedback reports. Here's how. 1. Top management. Strategic decision-making, predict trends in customer demand, optimize inventory, and improve forecasting. Business performance insights, identify bottlenecks in production or dispatch, allowing for long-term planning. Customer satisfaction analysis, use feedback data to improve product quality and service. 2. Middle management. Operational efficiency, optimize workforce allocation based on production and dispatch performance. Quality control, identify defects or issues in customer feedback and adjust production processes accordingly. Demand-supply balancing, ensure smooth coordination between order intake and production planning. 3. Operational level. Real-time monitoring, track production output versus planned targets and adjust workflows dynamically. Dispatch optimization, improve delivery routes and reduce lead times based on past performance. Customer feedback handling, identify trends in complaints and resolve issues faster. About, Python program using Random Forest with K-fold cross-validation to predict customer demand trends, optimize inventory, and improve forecasting. The program processes historical customer order data and applies machine learning to make predictions. Key features. Heavy Checkmark uses Random Forest for demand prediction. Heavy Checkmark implements K-fold cross-validation, K=5. Heavy Checkmark predicts future customer demand for strategic decision-making. Heavy Checkmark helps optimize inventory management. How this helps in strategic decision-making. 1. Customer demand prediction, forecasts demand trends to adjust production and inventory. 2. Inventory optimization, avoids overstocking or shortages based on expected demand. 3. Dispatch planning, ensures timely delivery based on future demand trends. 4. Feedback-based insights, uses customer feedback scores to refine demand forecasting. Explanation of the graph, generated by Random Forest with K-fold CV. 1. Graph overview. The graph represents predicted customer demand for 2025 based on historical data from 2005 to 2024. Random Forest regression was used with K-fold cross-validation, K=5, for robust model evaluation. The mean absolute error, MA, is optimized to approximately 43.65, improving prediction accuracy. 2. Graph components. Bar chart, cyan, rightward arrow predicted customer orders per month. Shows expected customer demand for each month in 2025. The height of each bar represents the forecasted order quantity. Trend line, red, rightward arrow monthly variation in predicted orders. Shows the fluctuation in demand trends across 12 months. The steep peaks and dips indicate periods of high and low predicted orders. Helps identify seasonal patterns or anomalies in demand. 3. Interpretation. Small blue diamond consistent order volumes. The bars are mostly stable, indicating consistent customer demand throughout the year. There are no extreme variations, meaning market stability is expected. Small blue diamond fluctuating trend line. The trend line shows short-term variations in monthly demand. High peaks indicate surges in orders, example seasonal demand increases. Low dips indicate periods of lower demand, example off-peak seasons. Small blue diamond cross-validation performance, K-fold. The K-fold cross-validation ensures that the model is trained and tested multiple times, preventing overfitting. The optimized MA of 43.65 suggests that the model performs well with minimal error. 4. Business insights. Understanding demand fluctuations. Can help with inventory management, ensuring stock availability aligns with predicted demand. Help with staffing and production planning based on expected order volumes. Marketing and promotion strategy. High demand months rightward arrow opportunities for targeted sales promotions. Low demand months rightward arrow need for additional incentives or discounts to boost sales. Supply chain optimization. Helps in logistics and procurement planning to maintain optimal stock levels. Prevents overstocking or understocking situations. Final thoughts. The Random Forest model with K-fold CV has generated reliable forecasts. The cyan bars indicate predicted orders, while the red trend line shows monthly variations. This data-driven approach supports better decision-making for business operations in 2025. How this image supports Decision Support Systems, DSS. The graph you provided is a data-driven visualization that can help managers and executives make informed decisions in business operations, supply chain management, and customer demand forecasting. Below are key ways this visualization aids a decision support system, DSS. Bar chart 1. Demand forecasting and planning. What it shows, the bar chart, cyan, represents predicted customer demand for each month in 2025. DSS impact, helps in inventory management, production scheduling, and procurement planning. Example, if demand is expected to be high in March and July, the company can pre-order raw materials or increase workforce capacity. Chart increasing to. Trend analysis and seasonality. What it shows, the red trend line indicates fluctuations in demand over 12 months. DSS impact, identifies seasonal trends and business cycles. Example, if orders drop in April and August, marketing teams can plan promotions or discounts to increase sales. 3. Resource optimization and cost reduction. What it shows, peaks and troughs in demand indicate fluctuations in customer orders. DSS impact, helps in workforce planning and budget allocation. Example, if demand is low in certain months, companies can reduce overtime or reschedule shifts to optimize labor costs. 4. Supply chain and logistics management. What it shows, the demand prediction helps in supply chain adjustments. DSS impact, ensures on-time delivery and prevents stock shortages. Example, a spike in demand in May and November means logistics teams need to secure more transportation and warehouse space. 5. Risk management and decision making. What it shows, monthly variations in demand can indicate potential market risks. DSS impact, helps businesses prepare for unexpected drops in demand. Example, if there is an expected sharp decline in orders in Q2, managers can adjust pricing strategies or explore new markets. 6. AI-driven predictive analytics. What it shows, AI-generated demand forecasts using Random Forest and K-fold cross-validation. DSS impact, supports data-driven decision-making instead of relying on guesswork. Example, companies can use this AI model to test different scenarios, example price changes, new product launches, and analyze their impact on future demand. Conclusion, how this graph enhances DSS. Data-driven insights, AI-based prediction enables proactive rather than reactive decision-making. Operational efficiency, helps in scheduling production, managing inventory, and allocating resources. Competitive advantage, companies can identify trends, reduce risks, and optimize profits. Thank you.